Good morning, Econ Nation. It is now August 1st. We've made it to August. Side note, it's also my sister's birthday. Today we are going to be talking about the shape of indifference curves and whether or not goods are what we call substitutes or complements. When we think of two different goods, they can be related to each other in two different ways, actually three, because some goods can be neither substitutes nor complements. The first idea is complementary goods. So these are items you tend to consume together. So some examples would be peanut butter and jelly, shoes and socks, beach towels and sunscreen, yada, yada, yada. Substitute goods are items that can take the place of each other. They substitute for each other. Some examples would be butter and margarine, Coke and Pepsi, Gatorade and Powerade. Another classic example is gas stations. If there are two gas stations across the street from each other, the gas from those two stations they're substitutes for each other. So we're going to look a little bit at what indifference curves look like for goods that are perfect substitutes, perfect complements, and then what it might look like in between those two extremes. So the first one we're going to look at are perfect complements. So this graph illustrates the indifference curves for two goods that are perfect complements. The classic example of perfect complements are left and right shoes. Most people will always consume one right shoe with one left shoe. So you're always going to consume shoes in a 1-to-1 ratio. And so when we look at the indifference curve, why is it shaped like a right angle? So if I'm at point A, and let's say you give me, so right here I'm consuming 6 right shoes and 6 left shoes. And let's say that the horizontal axis is right shoes and the vertical axis is left shoes. If you give me 4 more right shoes, so I'm still here, I still have 6 pairs of left shoes, but now I have 10 pairs of right shoes. That doesn't increase my utility at all. I'm still on the same indifference curve because, great, you gave me 4 more right shoes, but you didn't give me any left shoes to go with them, so I don't have any pairs of shoes to wear. So I'm not any better off than I was before. If you're going to make me better off, you're going to have to give me pairs of right and left shoes. So if you want to give me 4 more right shoes and 4 more left shoes, that would put me at this point, and now I would be better off. So I would reach this indifference curve up here. The reason the indifference curves are right angles is that if you increase one type of shoe without increasing the other, you still end up on the same indifference curve. And that's what these lines represent. So if I went up from A, that would be like you're giving me more left shoes, but no more right shoes. So you still haven't made a new pair. So that's why the indifference curves are shaped this way. This just shows that, so this illustrates what would happen if for some reason the price of right shoes, doubled. So let's say right shoes were twice as expensive as left shoes for some reason. Instead of the red budget constraint, we'd be on the purple one, and we would be at point B. We would drop to point B. So your consumption of right shoes went down, but because you can no longer afford as many right shoes, your consumptions of left shoes is also going to fall. So this is one of the key definitions of complements. So X and Y are complements. If when the price of good X goes up, your consumption of good Y goes down. The way to think about that is when the price of good X goes up, so here's a little chain that explains that. That means you're going to consume a smaller quantity of good X. But because X and Y are complements, when you consume less X, you're also going to consume less Y. Okay. Okay, now we're going to look at perfect substitutes. So let me talk a little bit about this graph because it's a little confusing because everything's straight line. On this graph, the red line is the budget constraint. The blue and the green lines, those are indifference curves. The indifference curves for perfect substitutes are linear. Here we have two goods. So this is the situation you want to imagine. You're at the grocery store. You need to buy bottled water. So you're in the bottled water aisle. How do you decide which brand to use? So let's say, and for purposes of this example, all bottled water tastes the same to you. You don't really have a preference. So when you are in the aisle, how do you choose which brand of bottled water to buy? And would you ever end up buying a mixture of two different brands? And the reality is that if you think about it just logically, when you go shopping and you're in the aisle and you don't really care what brand it is, you're going to look to see which one's on sale or which one's the cheapest. And then that's the brand you're going to buy. So because different brands of bottled water are perfect substitutes for each other, really you're just going to end up buying the brand that's cheaper. And that's actually what this graph demonstrates. So let's say that brand X is on the horizontal axis and brand Y is on the Y axis. In this diagram, you can tell that brand X is cheaper because if I spend all my money on brand X, I can get 16 bottles of water. If I spend all of my money on brand Y, I can only afford 8 bottles. So brand X is half the cost of brand Y. So if I spend all of my money on brand Y, I end up on this blue indifference curve right here. If I spend all of my money on brand X, I end up on this green indifference curve. So in that scenario, I'm always going to choose to buy all brand X because I am on a higher indifference curve when I do that. The green indifference curve is higher than the blue one. And you can also see that we're never going to buy a mixture of the two brands, so I'm not going to end up at this point because if I bought this point, I would be on an indifference curve somewhere between the two that I drew on here, and I could still do better by shifting my money, spending more money on brand X. So in perfect substitutes, you always end up with a solution where you buy only one good, you spend all your money on it, and you're on one of the axes. In order for you to switch brands, what would have to happen is that the price of brand Y would have to go down until it's cheaper than brand X. And then once that happened, you would you would buy only brand Y. All right. So the definition for substitutes is similar to complements. Well, so just some takeaways. The indifference curves for perfect complements are right angles. The indifference curves for perfect substitutes are linear. Indifference curves for goods between these two extremes fall on a continuum between right angle and linear. So an indifference curve that looks like this, those goods are probably complements because it looks sort of right angle-y. Indifference curve that looks like this is price substitutes because that's becoming more linear. So this is the rule we talked about the definition of complements. If two goods are complements, when the price of good X rises, the consumption of both X and Y go down. if two goods are substitutes, then when the price of good X rises, then your consumption of good X will go down. But because you can substitute good Y for good X, when X becomes more expensive, you're going to buy more of good Y to substitute for it. So many pairs of goods are neither substitutes nor complements. So like cooking oil and dog food, for example, are neither substitutes nor complements. The price of cooking oil has like no effect on how much dog food you consume. Those are items from my grocery list the other day. If the price of good X changes, it will have no impact on how much of good Y you consume. Okay, so let's look at some quick examples here. Okay, so the question is, when you look at these, what color do I want? I'm going to go with that one. When you look at this diagram, so this is a diagram where we started at point A, the price of X fell, so we got a new budget constraint at B. Are these goods substitutes or complements? So take a second, put your answer in play, pause it. Okay, so let's look at what happened here. So when the price of X went down, we ended up consuming more of good X and more of good Y. So that means that these two goods are complements. So price of X went down. That means we ended up consuming more of good X. And we can see at point B, it is above point A, so that we also ended up consuming more of good Y. So that means because consumption of the two goods moved in the same direction, that means they're complements. They're obviously not perfect complements because these indifference curves aren't right angles, but they are still complements. All right, next example. Okay, so here when the price of X went down, I end up consuming still the same amount of good Y as I did before. A and B are on the same horizontal line. And so I did end up consuming more of good X. That's always going to happen when the price of a good goes down. You're going to consume more of it. But it didn't change my consumption of Y. So these two goods are neither substitutes nor complements. All right, one more. Okay, so go ahead, put in play, pause it, whether you think these two goods are substitutes or complements. It turns out these are going to be substitutes. And actually, this is a situation where the price of good X went up. So we started at A, so price of X went up. That means we're going to consume less of good X. So we move here. And we end up consuming more of good Y. Point B is above where point A was. Okay, so that means these two goods are substitutes. So when good X got more expensive, I was able to substitute some of good Y. So this would be like butter got more expensive, so now I'm going to buy more margarine. So these are substitutes. All right, I think the last slide is just textbook examples, which is great because we were almost out of time. So if you want some practice problems, there they are. Thanks for listening, and I will see you soon.